Hi, my name is famous comedian Jerry Lewis. Just kidding. I think he passed away. But so my name is Sean Goggins. I'm one of the co-founders of the Chaos Project and the maintainer of the Augur software that's part of the Chaos Project. I'm going to talk about the contrast between corporatized open source software and open source scientific software. There are some interesting high-level contrasts, and we're just getting started there. I want to emphasize a couple of things, three things aside from this main point. First, building a community is the most important thing when you're trying to build something like a research software engineering profession or an alliance. You have to have a community around it. It is the same with open source software. And I think with scientists, so often we forget the part about building a community, and software doesn't get maintained or kept alive while it still has significant scientific utility. The second thing is that building a community is a lot of labor, and it includes not only the software, but all of the things around the software that are significant. And finally, and also important, is the goal that we have, the aspiration that we have, is to center our community, our open source software community, around diversity, equity, and inclusion. And we're doing that for several selfish reasons. One, we think it's the right thing to do, and altruism is ultimately selfish in my view. Two, we don't want to leave more than half the world's labor force out of all the work that we have to do. So community, it's hard, and building a community focused on diversity, equity, and inclusion, we think, is a path to success. We've been around for 5 years. I don't want to say that we're going to keep going, but we've been successful building a community, I think, because we've done those three things. What's now what I'm really going to talk about? Oh, the participant meeting has been recorded. Good to note that. I'm going to talk a little bit about Augur, but I'm going to hit you with some of what I think the two significant contrasts between open source scientific communities and open source corporatized communities. That's not my slide, so I get confused. So look, the title slide. You can tell me if it's not up there. It's okay. I tell my students this all the time. I forget this.
I was enjoying your freestyle.
Oh,
What
Will you see me on the ski slopes? I'll break a leg, literally. So defining open source health and sustainability. This is what Chaos does. We're helping communities. So we built the community, but we're also helping a lot of open source communities to organize and tell their own stories, recognize what are the new frontiers. So there's always the open source part of your work that is what you're doing right now and is bringing in the grant money or generating revenue right now. But it's also important to keep an eye out for what's happening next so that you can sustain yourself. Augur is one of the tools that we've used to construct and express metrics and understand how DEI can be understood through the trace data. And we've also opened a badging program, which you can find at github.com/badging, which badges events following a checklist for open source diversity, equity, and inclusion. This year, we're initiating a project badging program that is going to be a significantly heavier lift, and we haven't figured it out yet. If an event happens once, badge it once, you're done. A project, it's an ongoing phenomena, and it will take creativity. We haven't sorted out how to do it yet, but we think automation is going to be part of it. And so we think of ourselves as partners with the community of people here for advancing the next generation of open source software. Now I want to hit you with just a couple of really quick charts to explain or show some of the very simple contrasts we've shown or identified between open source scientific communities and corporatized ones. This is a corpus derived from 3,500 open source projects randomly sampled from the Linux Foundation's thousands or tens of thousands of repositories, and 2,203 open source scientific software projects that submitted proposals to the Chan Zuckerberg Institute. So we have, I think, a pretty good sample. They're not equivalent, but they represent a solid cross-section of those two spaces. First, we did sentiment analysis of every message in every repository using there's a software engineering sentiment analysis tool, Sentisoft, Kelly?
SD or.
Yeah, Kelly told me about it, so that's how I. Yeah.
Sentimoji, SentiCR.
SentiCR. It was SentiCR. Yeah, it was SentiCR.
What do you mean by sentiment and emotion? Or?
Expression of a positively or negatively valenced form of communication.
Balance.
Depends on where you're from. It's a culturally sensitive word, right?
In
Valence is, I say,
this model of emotion which operationalizes emotion along 3 dimensions: valence, arousal, and dominance.
Mhm.
And valence is exactly this positive, negative. Arousal is the amount of energy you're putting in it. For instance, if I'm positive, but my arousal is low, then I'm content.
we weren't aroused, we were just
I'm
valenced.
arousal high and I'm positive. But
Okay.
I'm excited.
All right, thank
What's
you.
the third?
Thank you.
Dominance. Do you feel in control or do you feel controlled?
Oh, okay.
It's,
I'll talk to my therapist about that one.
It has special done.
Yeah, so these are the numbers and they're a little bit hard to read, but the negative numbers, this is a histogram. The negative numbers for open source scientific software communication are this one little bar here for these 2,203 projects. And the higher valences are significantly higher towards the end. So we find the communication in the comments sections of open source scientific software, pretty positive. People are upbeat. It's not a place where there's a lot of rampant hostility. Then we go to the corporatized universe. This isn't a judgment in any way, but these are people who are paid, who are under time pressure, who are not pursuing the joy in their life of a scientific research project. They're people who they just got to do this and they got to make a comment and they can get annoyed. And we see a wider distribution here. And we also see that the more negative sentiments do appear up through here. So there's a decent peak of negative sentiment and then not a bad distribution of more positive sentiment. But you see two very different ways that people communicate valence wise with positive or negative emotion.
I just had a question from Yo. The number scales seem radically different from the last graph. Why is that?
Because it's distributed by what the data is. So I didn't do anything to normalize these graphs. I also did not round this or z-score it. So I guess I made a mistake. Yeah, that's the difference. The distributions are the distributions that they are, and I didn't get the x-axis consistent, so I'm sorry about that. I'll distribute a copy with the consistent x-axis on the Slack channel.
But it suggests that the data is different in scientific sentiment compared to the corporatized sentiment, right?
It's the data in terms of like the distribution that I'm
The
showing.
range, for example.
That it's not when I z-score it.
No, but I guess Yo's question is about before Z scoring, it's so different. Why is the range so different between the two contexts?
Because I didn't normalize why is the range? Not just we're not fixated on the x-axis. We're just
Maybe I could
Oh, sorry.
rephrase. So it looks
Sorry.
like the second slide, everything is sort of like around about 1, whereas the current slide is 27,000. And does that mean that it's 27,000 times more positive?
That's my failure to normalize the distribution when I constructed the graphs. That's a statistical throwing a spreadsheet together error on my
Okay,
part.
so if we like overlaid one graph on the other, they would correlate to one another visibly. Right,
Yes.
thanks.
Yes. So I apologize for that. That's confusing. All right. Now, when we look at contributor counts again, so for the scientific software community, we're talking about 2,200 different projects. In the work that we do, we don't just count a contributor as a committer. We count a contributor as anyone who does so much as make a comment, open an issue, open a pull request. We also count the classic commits, but we count the comments and the issues. GitHub has started to refer to that as the community, but they still only count people who make commits as contributors. The philosophy that we've taken is that a contributor is anyone who contributes anything to a project. So these numbers will skew to the larger side compared to the GitHub statistics. So in scientific software, we see various ranges for the 2,200 projects of different kinds of contributions, from 25,000 all the way over to 26,000 rolling average. I'm sorry, I get that. Let me say this correctly. These are my repository IDs. This is the y-axis is the count of contributors of any kind across a scientific open source project. And you'll see that for the most part, when you count comments and all of the things, there's not a substantial range among the 2,200-ish projects that CZI had. I have a couple outliers at the end. I have to look into why that is. With corporatized open source software, you want to know where all the dead repos on GitHub are? They're corporatized projects, right? When somebody applies for funding from Chan Zuckerberg, they're not submitting for a dead project. When I look at the universe of corporatized open source software, I see a large quantity of dead projects with very few contributors that are active over the last 2 years. And I see a larger number of projects, or a smaller number of projects, maybe larger in the aggregate if we looked at the universe, but I see a lot of dead projects in the corporatized space. And I also see a larger N for the total number of contributors in the corporatized space. So in the corporatized space, we have dead repos, and we have a larger total N of contributors. So you can see the scientific contributors, they kind of peak out around 75 in most cases. In the corporatized space, you can see that they peak out in the 250 over a couple-year period. But a lot of the repositories that fall under the corporate domain have been dead for 2 years and just not called. So when we talk about open source software health and sustainability, I think it's really critical, especially for research software engineers or anybody who calls themselves a software engineer, to understand there are these different spaces where what open source is and the culture that you enter and how you live in it is, it's just very different depending on the kind of project that you're working on. I could end here, and that would be like the little summary story of there's a stark contrast. What I want to tell you about is we also have, so I look at messages as a way to tell a story about an open source project that's distinct from counting things like only activity. And we've built in Augur and Chaos a pipeline for machine learning that does take into account sentiment, but also message activity, high communication activity, highly active negatively valenced threads, and a phenomena. We also use topic modeling and clustering, but that's kind of a separate thing that's not entirely associated with messages. We use a discourse sequencing model. So we're starting to profile how questions, answers, assertions, disagreements, the 10 basic parts of speech sequentially vary from project to project. And so that's the direction that we're headed. And again, we think we're going to see very different phenomena across open source scientific projects and open source corporatized projects. So let's talk about, I want to talk about these valence messages really briefly. This is a simple table where we have a repository and a summary of the valencing of that message. And if I was to look at a scientific repository, for example, monthly, and I just have to get my zoom out of the way so I can read what that says. So from these repositories, from the 2,200 open source scientific projects with recently valenced, imbalanced messaging, I have these projects, which inadvertently I'm calling out a little bit, and they have a higher negative ratio for these time periods than otherwise they would have had. And I put a limit of at least 50 messages over here. So I can see that, and I can see, okay, if I'm a community manager or a person concerned about a project, I can get notified that all of a sudden there's a lot of valence messages on negatively valenced messages on a project from when compared with the month before. I could do the same thing then with corporate repositories, and you'll see when they don't go dramatically different in terms of when the negative ratio becomes higher. And so in this case, I've got another set of repos that have, so if we look over time, these are repos that have had what I would call anomalous negatively valenced messages. So we look at messages over a long period of time. These repositories do not have a long history of negatively valenced messages. We found a spike at a point in time. And so we can notify the person who's looking over that community of that spike. And this is how it connects relationally. And this then brings us back to the thread. So you get negatively valenced messages on GitHub, right? Those are associated with an issue or pull request. What's important is not to find that specific message so much as it is to find the thread within which that negatively valenced collection of messages existed. So this is where we find the top level issue that those negatively valenced messages exist in, and we can do the same thing for corporate. And through the Augur interface in our next edition, then when we find these anomalous messages where a repository where everything was hunky-dory goes negative, you can click on it and actually get to the GitHub issue to determine if that's really a negatively valenced message or if it's just something that you shouldn't care about, and then give feedback to the system. So this is a bug report that talks about a scattered plot. It uses, I would speculate that we got the negative valence because we talked about words like bug, although that should be left out, but crashes, it just ends. And then there's some things below that we can go to then that negatively valenced message and then determine what happens with it. Additional analysis that we're working on is discourse analysis, like I mentioned, which from a science, again, we think that these, and we've got good reason to believe this. So we've done experiments in a lab. What we're doing now is producing open source software that shows that the ways that people communicate, the patterns that they use to communicate within corporatized and open source scientific software is different. We see the number of people engaged in open source software, that scientific is different. And so by understanding the types of communication and the sequence of communication, clustering message patterns that are similar, we can identify similar repositories. And then not only can this help for a project to understand where it fits in its larger ecosystem, it can also be used to help identify what I would characterize as statistically significant, quantifiable impediments to advancing diversity, equity, and inclusion in an open source project. If we can find messages that appear from nowhere and have a negative valence to them and possibly signal that something's going wrong or is alienating people from the project at scale, then it becomes easier for us to root out the things that impede equity and inclusion in open source software. That's something that can apply to both corporate and I'm just gonna skip past this. Just gonna skip past it because I think I made my point. Any questions?
Thank you, Sean. I'm curious about, you talked about the negative valence, and from the perspective of community, how does that, so having maybe a project or a repo that has negative valence, does that reflect on the diversity and inclusion within that repo? And does that affect how the community gels and how they contribute to that project?
So what we've seen in other studies, what other scholars have shown is that when you have what I'll call hostility or toxicity in a discussion thread on an open source project, that will drive away a lot of people, but it'll also drive away a more diverse, non-majority audience participation, contribution, community from it. And one of the things I didn't draw out that's kind of important is we're not looking at a point in time. We're looking at what is the pattern of culture on that project over time. So we're looking at anomalous up or downward movement that occurs at a point in time. So we're trying to catch events where something went terribly wrong, and it is the kind of event that we hypothesize is likely to drive people out of an open source community.
So it's a measure that something could be going wrong.
Yeah,
A community manager or the managers that report